Hi folks, and welcome back to Physics with Captain Rod. The purpose of this video is to demonstrate how to use the vector definition of moment to calculate moment about a point. And in addition to that, we're going to learn how to figure out how much of a moment vector is in a certain direction. So what we're going to do here, taking a look at this picture, we're going to take this 300 Newton force, which is straight down. We're going to calculate the moment vector about point A. And then what we're going to do is we're going to calculate how much of that moment vector is in the direction of AB. So in essence, what that means is how much of that moment basically is making this bar want to go around this axis. So moment, remember, is your position vector crossed with your force vector. So I'm going to start by writing a position vector that starts at A, ends at C. So I'm going to call that vector position AC. Now, x direction wise, you'll notice we've got to go 0.6 this way, so we're going to have 0.6i, and again I'll put the units out somewhere else. J direction, there's no displacement in the j direction going from A to C, so if we want we could put plus 0j. And then k direction, to get from A to C we've got to go up 0.3, so plus 0.3k. And I'll go ahead and put the units out here, these would be in meters. Right. So the moment vector, right, the moment produced by this force about point A is going to equal this position vector. I'll go ahead and write it, 0.6i plus 0j plus 0.3k crossed with this force vector. So this force vector is 300 newtons, and it's based on the picture, it looks like it's straight down, so I'll just put crossed with 300 in the minus k direction. And I think what I'll do is I'll just take the units and put them way outside of this whole deal. So when we take something with meters and we're essentially multiplying it with something with newtons, we end up with Newton meter. So now I'm going to go through and talk about, how to actually do the cross product. So I just go through these kind of term by term. So remember, a cross product is magnitude of the first vector, magnitude of the second. In fact, let me write this up here. If I were to take vector A, cross it with vector B, that's equal to magnitude of A, magnitude of B, sine of the angle between them. So when we go through and do this cross product, the first term we're going to have 0.6i crossed with 300 in the minus k. So the magnitude is going to be 0.6 times 300, and the direction is coming from I crossed with minus k. Now let's see, when I do that cross product, I get j direction out of that. So again, if you're wondering where this is coming from, review my video on how to tell the direction of a cross product for unit vectors. All right, next term. We're going to have this product. This is going to give us plus 0.6 times 300, and the direction is going to be, whoops, I'm sorry, I got to back up. Next term is this product, 0 crossed with this. It's just going to give us 0 because magnitude is 0, 0 times 300 is still 0, so that guy's done. Moving on, now we'll do this guy. 0.3k crossed with 300 in the minus k. Now if I write it out, that'd be 0.3 times 300. And then what we're going to have is k cross minus k. Well, k cross minus k is 0. I'll talk a little bit about why, because remember how vectors cross here. Magnitude of the first, magnitude of the second, sine of the angle between them. So when we do k cross minus k, the magnitude of the first vector would be 1, magnitude of the second vector also 1. Angle between them is 180, sine of 180 is 0. So the moment vector produced by this force about point A is looking like 0.6 times 300, and that's 180, I believe, 180 J Newton meter. So there's the moment produced by this force about point A. All right, next step is how much of this moment vector is in the direction of AB. So what I'm going to do here is I'm going to find a position vector from A to B. Now notice that we're going to have to go, let's see, this way. That's going to be 0.4i. And then this way is plus 0.2j. and these would be in meters. Okay. The magnitude of this vector is going to be the square root of 0.4 squared plus 0.2 squared, and if you give me a moment to calculate that, oops. All right, I get 0.447 out of that. Now that would be in meters. So now what I'm going to do is I'm going to take this and turn it into a unit vector by taking the position vector and dividing by its magnitude. In that first term I get 0.895. I'm just going to call it, we'll round that to 0.89. 0.89i. And that's coming from this divided by this. And then the other one, I get 0.447. Let me just check that again. 0.2 divided by. The other one I get 0.447 out of that. That doesn't look right. Well, 0.4, I'm just going to round that to 0.45j. This doesn't need units anymore because it's dimensionless. I'm just going to do a quick check here, make sure that this is going okay with Pythagorean theorem. Okay, yep, so this square plus this squared is approximately 1. All right, so now to get how much of the moment vector is in the direction at AB, that's a projection. I'm just going to take this vector and project it onto this direction. So what that's going to equal is 180j Newton meter dotted with this direction, 0.89i plus 0.45j. And when we do the dot product now, remember, when we do this first product, it's going to be 180 times 0.89, but j dot I is 0 because the angle between them is 90 degrees. Remember that with a dot product, you know, a dot b is magnitude of a, magnitude of b, cosine of the angle between them. But the angle between j and I is 90 degrees. So when we do this dot product, what survives is the 180 Newton meter times 0.45, and then j dot j is 1. I'll go ahead and put the 1 there, and when we multiply this out, we get about 81 Newton meter. Now, this no longer has a direction because, you know, when we take when we do a dot product, remember, you don't get a vector out of it. So what this is this is how much of the moment vector is about AB. So basically this force is producing a tendency for this thing to rotate a moment about this axis of 81 Newton meter. So the purpose of this video was how to calculate moment kind of in 3D using the vector definition of moment, which is this, and that's what was done right here and here to get this value, including the direction, and then to determine how much of that moment vector is in a given direction, and that's what was done here and here. Hope this video helps demonstrate these concepts. Have a great day.